Hello everyone. I guess now it should be fine as far as the audio is concerned. So my name is Marcin Kubacki, and today with me there is Jarek Stakun from RedHat. He is lead architect. So this is part 2 of our webinar related to the OpenShift for developers. So Jarek, if you could introduce yourself maybe a bit.
Yes, hello everyone. My name is Jarosław. I work as a solution architect for almost 7 years at RedHat. I'm focusing mostly on containerization, so OpenShift and all the, let's say, developer-oriented tools and solutions, including JBoss middleware.
My name is Marcin Kubacki. I'm Chief Software Architect at Storware. I have over 10 years experience in virtualization, middleware, software development. So basically, OpenShift is one of the areas that I also is also my area of interest. And now I guess we should start with a quick recap of the previous webinar. We talked about developer toolset that comes with the OpenShift. So if you could start maybe with a quick recap and tell us what is OpenShift in general and what is the agenda for today.
Yes, so we have today the second part of our developer-oriented webinars. So just to remind you what is OpenShift. So in general, OpenShift is the containerized application lifecycle management platform. So OpenShift gives you all the tools you need to build, to containerize your application, to build your application, deploy it and run it in production. OpenShift is based on Kubernetes, which is de facto standard for containerized applications. It also includes RedHat Enterprise Linux operating system. And also in the recent version, we introduced RHEL CoreOS, which is lightweight version of Red Hat Enterprise Linux, which is dedicated for running containerized workloads and Kubernetes. And then with OpenShift, you get all the tools that you need to develop applications and also to monitor them and manage the infrastructure. And today we focus, it's the second webinar where we focus on developer-oriented tools. This time we will talk about some technologies that are dedicated for kind of streamlining your application delivery.
Okay, so maybe let's start with CI/CD operations with OpenShift.
Yeah, so CI/CD in OpenShift is present since very beginning. However, since the beginning, we used to rely on Jenkins for CI/CD, and Jenkins is still here in OpenShift, but with version 4, we also started to introduce the new CI/CD platform based on the Tekton project. So the main difference between those two is that Tekton is more is basically built-in Kubernetes, so you don't need to install external tool like Jenkins, but you simply enable the functionality in OpenShift and you have it. So you can also the pipelines that you build, they are defined with YAML. So this is kind of standard way of describing the configuration in Kubernetes world, and we follow that also in OpenShift pipelines. So here you can see a small example, but I would like to show you how this solution looks like in OpenShift.
Maybe a quick demo, right?
Yeah, exactly. So let me just quickly switch to my console. So in order to deploy pipelines in OpenShift, you will need to install operator. So if you remember from the previous webcast, all the additional optional functionalities in OpenShift are available as an operator, so there is also one for the pipelines. So first thing is really to install that operator, and then when you install it, if you switch to developer perspective in OpenShift Web Console, you will see there will be additional pipelines menu item, and this is basically where you can manage your pipeline. So I have deployed one pipeline here, so you can see here the structure of the pipeline. It's kind of visualization of what we create in YAML file. I will just quickly start it, and then we'll show you how it looks like. You can define some resources in your pipeline, and then those resources can be provided as a kind of startup parameters for your pipeline. So here you can see some GitHub repo and some names of the images where we want to save the application that we are going to build and deploy using this pipeline. So I'm just going to start it. You can see 2 of the tasks in the pipeline has been started, and we can have a look now on the pipeline definition. As you have seen on the slides, it's YAML structure. So first you define resources, and this is what you can later provide as a parameters to your pipeline, and then you specify set of tasks in your pipeline. What is really important here is that each task in the pipeline is executed as a separate pod or container. So you will need to prepare, or you will use existing library of existing pipeline tasks which are implemented as a container images. So you will simply just spin up some container image in each task, and this task will execute the logic you want to. There is also a way to specify the order of execution for the tasks. So we have seen that 2 tasks has been started. This is because I didn't specify any order for these 2 tasks, but if you set for task some order configuration, like here you can see run after, this way you can specify the order of executing of the task in your pipelines. Also, that there are some more advanced configurations like conditional execution and so on. So you can configure here pretty complex pipelines. We can have a quick look here what's going on with the pipeline I executed. So it takes quite a time here, so we will not wait till the end, but you can see here that still 2 tasks are executed. So you can see the log of the containers that are executed within each of the tasks. And then maybe we come back to later on and see how this pipeline has progressed.
Okay, so maybe now a bit different topic. What is Service Mesh? When I would need to use it?
Yeah, so Service Mesh is quite important functionality especially for microservices-based applications. Where you need to implement the communication between the network of microservices that will create your application. So with Service Mesh you can use external layer where you can implement this network communication between the services. You can implement and later you can monitor how the traffic is moving between the microservices within your application. So this is the kind of architecture of Service Mesh. So you can see there is a control plane where you configure your mesh, and where you have tools to monitor your service. And then in the service you want to be managed by the mesh. You need to add additional sidecar container called Envoy proxy, and with that proxy all the communication between the services will be routed via this proxy. So this is the place where all the policies you will define will be executed according to your Service Mesh configuration.
Okay, so now my application grows. I have tons of microservices. I want to easily scale up and down based on my demand. So how can OpenShift help me to do that?
Yeah, and this is where you can leverage another functionality, which is OpenShift Serverless. So with Serverless, you can scale your applications up and down based on the real traffic, real workload that will be executed and sent to this application. So with Serverless, you don't need to define all the deployment configs and all the configurations to deploy and run your pods. You simply define a service, and with this service, and the service will be scaled automatically up and down by OpenShift based on the real traffic that will be generated for the application. I will show you how this serverless functionality looks like. So this time I will switch for a while to the console. So it's pretty simple to configure. The first thing you need to do is to define the service. So the service in the service you define what image should be executed. So from what image should be started the pod or container with the service. And you can also configure some annotations for the autoscaler that will be configured for your service. So here you can see I have configured one annotation where I'm saying that I want to have at least one instance of this specific service to be to run, and this tells the autoscaler to run my at least one instance of a pod with this from this image. So let me just execute that. So this should create for us the new namespace, as you can see, so the new project and the service itself. Now we can have a look. Into the web console. So here is our so here is the project I created. You can see the one pod is already running, but if you switch to administrator view, you can see the whole configuration. So here is our service I have created. So the revisions are basically the versions of the service. So I will show you in a minute how to create a new one, and then the root. So the root is basically the ingress to our service. So this is how we expose the service to the public network. So we can call it, and you can see here that version 1 has been executed. So now let's make a new revision. So I will simply change. I will just change the comment that will be sent or shown when we call the service. So I'm creating a version 2. This creates a new revision here. You can see, and now we have to wait for a while until the new the new container with the new revision will be started. So if we come back now to the developer perspective, you can see here that the new version is starting. We can try to call the root. You can see that still old version is replying. Okay, now it's starting. So hopefully we'll see. Yeah, version 2 is sending. Is working now. And now let's say we want to kind of simulate the blue-green deployment. So we want to test both versions, so the new one and the old one. So we can do that because we have 2 revisions, and we can now define a root where those 2 revisions will be called with some percentage that we specify. Okay, so for that we need to we need to create a new root where our revisions will be called with by 50% each. So this means that more or less the same request will be routed either to one or to the another. I just need to copy the name of the revision. So this is the key thing here to get this work. So just let me do it that way, and let me create the root. Serverless root. Okay, we have new root here created, so we can come back to the console. We have a root here, as you can see. Now we need to wait so that both revisions are running. But what we can also do, we can call here just simple looper that will call the root, and hopefully in a few seconds we'll see the responses. So you can see that we get the responses from version 1 and version 2 more or less equally. So this is the power of serverless, that you can very easily create different services and revisions, and the scaling and execution is managed by OpenShift.
Okay, so maybe another topic. Most of our projects are Java-based applications. These are usually quite heavy as far as when you run them, right? So how this particular thing can be approached?
Yeah, so this has been a challenge in when you wanted to migrate your existing Java applications into containers, because Java has been designed many years ago before containers, and the challenge with Java in containerized world was that first of all the startup time of Java virtual machine based application is quite long, and the second challenge is that typically it consumes a lot of memory. And those challenges, the solution for those challenges has been developed, and there is a project called Quarkus. So the Quarkus aims exactly on optimizing the way how Java is consuming resources. So with Quarkus, you can build, you can compile into native machine code your JVM application, so that it consumes significantly less memory and starts much faster than regular Java code. We can, so the goal here is really to make Java awesome on Kubernetes. So it means to make it agile and fast in terms of startup and consumption of the resources. I will show you quickly real example how this was the difference between the consumption of resources in Java based applications and in Quarkus native code. So I have here some application which basically does pretty much nothing. So it's hello world, but I built it using the first version is built using the Spring Boot framework, so kind of most popular framework for building microservice based applications. So if we look on the pod that is running, you can see it consumes 270 almost 273 megabytes of memory. Also, if we take a look on the log, we can see here that the startup time, so we cannot see it exactly, but you can see it was more than 5 seconds. So in general, this was probably around 10 seconds to get this process started. And what it really does, it's simply, sorry, I clicked the wrong link, this one. So it's really kind of hello world service, so it just it does almost nothing. But if we look on the same code built with Quarkus, so again we look on the pod. So this is the Quarkus that is executed in regular JVM. so this is not yet natively compiled Java, but even with regular JVM, you can see that the consumption is significantly lower. It's 167 megabytes, and the startup time is also quicker. So here you can see exactly it took like over 6 seconds to start. But the biggest benefit will be when you will take a next step and you will compile this application source code into the native image. And here we can see that the memory consumption here is almost 44 megabytes. So it's like compared to 273 is like, I know, 8-9 times less. And also the startup time for this service is super fast, so it's less than much less than 1 second. We can even make a quick test here. So if we switch to the second view, and we can basically sorry, I could have done this faster, but you can see here that when we kill the pod, the new revision will start just in very fast. And actually, the time it takes is to pull the image and to and is the time of refreshing our web console. So the process itself starts super fast. I mean, should start. I think it's pulling image now, so maybe now the effect is not so spectacular, but you have to believe me that it will work that way. Okay.
Okay, so what about more sophisticated applications that use, I don't know, messaging or other integration patterns?
Yeah, so as you probably know, at RedHat we have a large portfolio of JBoss middleware products. This includes both the application runtimes, including our most popular JBoss application server, but also some microservices frameworks like MicroProfile or Vertex or the others. And also we provide with within the JBoss family the integration platform. So this includes messaging you mentioned, also the streaming solution based on the Kafka, the Fuse integration platform, which is based on the Camel framework, and the 3-scale API management platform. And in addition, there is also another product family for process and automation and decision management, and this is where we have our workflow solution based on BPM and 2.0 and the decision manager for implementing some business decisions. And all those products has been available for quite a long time at RedHat, and we also containerize each of those products, so you can run them also in your container platform, just like you do it on regular non-containerized environments for a long time.
So far we discussed, I believe, mostly Java-based apps. What about other languages?
Yeah, so for other languages, we also we provide a universal base image. So this is the base image, which is based on the RHEL distribution, and it's free to use in any environment, any container environment. So you can use it in both RedHat environment as well as third-party environments. And also we provide here some pre-built languages images where which you can use to deploy other types of applications like Node.js, Python, Ruby, PHP, and so on. So the most popular open source based application frameworks and also .NET Core are supported, so you can use those images for free and use them in an environment to deploy your applications. All right, and this has been the last topic for today. So if you are interested in any of those solutions, if you want to just play with OpenShift or play with some of those technologies, I encourage you to visit the learnopenshift.com page, where you can take for free online hands-on trainings and play with some of those technologies. If you want to take a step further and you want to install the OpenShift in your environment, either on-premise, on your data center, on the cloud, or even on your laptop, have a look at tryopenshift.com webpage, where you will where you can download the installer for OpenShift version 4 and install OpenShift in one of the environments.
Thank you for today, and if you still want to know anything else, grab obviously the resources that Jarek has mentioned. Drop us some messages on LinkedIn, on other social media, and stay tuned. Thank you.
Thank you very much.